All right. Good morning. Happy Saturday. Let's get that out of my pocket. Let's see here. Let me this out. All right. Did this window update? Yeah, okay. The chat was frozen earlier. I had to reset it inside of OBS. I also crashed my OBS right when I was getting ready to start a few minutes ago, so I ended up rebooting. Let's see. Rebooting, and then once I rebooted, everything was all good. How's it going, Steve Grover? Good morning. Some coffee here. Piece of pie sounds pretty good, but I'll be going out to eat later. Some yummy food later on today. Let's see here. This one. All right, let me put those back on top, and then we are good to go. How's it going, Scythe? Sunny beer o'clock here. Nice. Always a good time of day. All right, so welcome to everyone. Thanks for tuning in. Happy Saturday. Today, I will be doing the stream as usual. For folks that don't know, my name is Tim. I go by Foamy Guy on GitHub and Discord, as well as Twitch, kind of, although Twitch, it's like Foamy Guy _ Twitch, because I was not first to the punch there. But most other places, I'm Foamy Guy online. I tend to stream at this time every week, Saturday mornings, 10 a.m., and I usually work on something related to CircuitPython. From week to week, it differs just depending on what I have going on or what I'm interested in or what's got my attention that week, basically. So it's not always the exact same thing, but it does typically revolve around CircuitPython in some form or fashion. If you don't know what CircuitPython is, you can learn more at the main website for it right here, circuitpython.org. This is basically a version of Python that can run on these tiny computers, which are called microcontrollers. These devices, when you use them with CircuitPython, you will run CircuitPython on there. You plug it into your computer, usually with the USB cable. It will show up like a thumb drive, and then you can edit the code files on that thumb drive. There will be a code.py, a Python code file. You just edit that file, you write some new Python code in there, and then you save it. And the computer that is inside the chip on these little devices will actually read that Python code, interpret it, and execute it on that little computer. And then it can interface with like all sorts of other hardware peripherals. Lots of these microcontrollers have loads of what they call I/O pins along the sides there, where you can hook up other bits and bobs to it. But some of them use different connectors like alligator pins, or some of them are, more fancily designed. Some of them have built-in screens and some other different connectors, not as many I/O pins. So there's a whole range of shapes and sizes and capabilities of these microcontroller devices. And there are 495 of them that support CircuitPython right now. So we're almost to the 500 mark there. And again, if you want to learn more about those, circuitpython.org is the place to do that. CircuitPython is open source, but it is financially supported by Adafruit. This is their website, adafruit.com. Adafruit is a hardware and software company based out of New York. They manufacture lots of the microcontroller devices themselves, and they also design and manufacture all sorts of kind of like add-ons and stuff for you to do with your microcontrollers, such as, on the newer side this week is a proto-doubler PiCow Pico. So this is a Raspberry Pi Pico doubler, much like the Feather doublers that they have, which is actually pretty cool. I hadn't seen this before, but I'll probably be picking these up at some point because I do find the Feather doublers quite handy. So all sorts of things like this that are either, the microcontrollers or the add-on stuff that you can do with the microcontrollers. You can find all of that sort of stuff over at their website, adafruit.com. And as always, thank you to everyone who purchases hardware from them, because you're helping them be able to keep paying the folks who work on the project. There is a team of folks who gets paid to work on CircuitPython project full-time. Wow, this background is like very mesmerizing. And there are other folks like me who are paid to work on the project part-time, and Adafruit is who makes that possible. And ultimately, it is you and those of everyone who purchases hardware from them that really makes it possible. So thanks to them, thanks to all of you. How's it going, DJ Devin? Hello, and Future Tim, if you watch this video as a refresher. Nice, yeah, thank you. That is definitely a convenient thing about recording yourself doing stuff, especially doing new stuff for the first time or whatever. This is not brand new, but it is like one of my first couple of times doing what we're going to do today. Once it's recorded, I can kind of go back and watch it for a refresher. So that is totally true. And thank you. I'm sure Future Tim will say hi to you as well when he gets the chance. Okay, so what do we want to do today? Today we are looking at something a little bit on the periphery of CircuitPython. We're not necessarily dealing directly with CircuitPython for the main part of what we're doing, but we will be using CircuitPython devices to upload data into a server that we're going to be making and running on a Raspberry Pi. So let me set the stage a little bit with the players that will be in play during this kind of situation here. So I don't have the camera. I don't have the camera set up for it, but I do have a Raspberry Pi 3 B+. Okay, just a standard Pi 3 B+. I was actually on the B, not the B+, but I've got one of these things. I am connected to it with SSH right here, so this is the Raspberry Pi. On the Raspberry Pi, it is running PostgREST. So for anybody that doesn't know, PostgREST, this is a very widely used open source database engine. You can run this on your personal computer, or more typically, you would run this on like a server, which you're connecting to the internet, and then you'd have some web application that's interacting with the database or something like that is kind of a typical use case for PostgREST. PostgREST, it's a really cool project. I've used it a lot for some of my work outside of CircuitPython, just as the database behind web applications and things like that. So I would say that I'm somewhat familiar with PostgREST, but I would also say that I don't really venture outside of the bounds that I use it for that frequently. And pretty much the main thing I use it for is just setting up the database for that web backend. And then in my case, I actually have an ORM, which makes it so I don't really interact with the database at a low level. It just kind of exists and backs up my data and is able to return it back to me as objects. So I'm familiar with setting it up. I'm familiar with some configuration bits, but I'm not familiar with all the different things it can do. And it turns out it can do a lot of different things. I found myself watching a couple of videos on YouTube recently. I don't have those linked. I should grab the links to those, but I fell down the rabbit hole a little bit of watching videos that are about different things you could do with PostgREST. And one of the ones I should say that caught my eye was this project called PostgREST. A play on the name PostgREST with the rest capitalized there, because what this thing does is it takes your PostgREST database and it turns it into a RESTful API. So you can define some tables, and then you can run this thing here, and then based on how you define your tables, this thing will just spin up a full API for you that lets you access and update and delete and manage all the data that are inside of those tables using an HTTP API over the network or over the local host or however you want to do it. So that's really cool. This is kind of the core two components to this project is PostgREST, PostgREST, which runs on top of PostgREST to create that API for us. Couple of the other sort of minor players here are Nginx web server. Nginx is just a commonly used web server. It's a lot like Apache, if you've ever heard of Apache web server. It's going to serve, in our case, just static HTML files and JavaScript files. Those files are then going to have JavaScript inside of them, which is going to interact with our database using that HTTP API, which is ultimately backed in PostgREST, of course. So we're just using it to host some static HTML and JavaScript. We're not doing anything else fancy with Nginx, but it is in the mix. And then we have a JavaScript library in the front end called Apex Charts, which we can use to chart some of the data that we pull out of the database. So we're automating APIs now. Yeah, it's sort of automated. Yeah, you could definitely think of it that way. It's like a way to set up your API. I mean, it automates it from the database, but you do have to set up your database with that in mind, I guess. It's not necessarily like just give it any database and then run it and then you get exactly the right API that you want. There's definitely more nuance than that, but at a high level, it is definitely you just set up your database in this way that it's ready for it, and then you just run it and you do get an API after that, which is actually really, really cool. So I have played with this a little bit, but the bits that I played with were actually on my local computer inside of Docker rather than on the Raspberry Pi. But I do intend to ultimately use this project on the Raspberry Pi, and I figured that would make a good thing to do on the stream. So where I am at specifically, now you know what I'm doing. Where I am at specifically is I've got the Raspberry Pi here. We are SSH'd into it. I have PostgreSQL installed, which we can verify by going like sudo su postgres to take us over to the Postgre user, which is a user that comes along with the PostgreSQL install. When you install it, you get this user. We're in this home directory. We don't have anything else in there yet. I think the 15 is just that's like a folder where it stores data or something. I don't know. We're not going to touch that, but it is there. So I have database installed. We could jump inside of it to even be super duper sure. So PSQL, that gets us to the database shell. We don't really need it right now, so I'm going to back out of that. I'm going to back out of that. I have PostgREST, which is right here, and that just runs as a file, I think, just like this. So it's chmodded to +x. I'm going to kill it here before it keeps just spamming my screen. But that one we just run right like that, and it's good to go. It's telling us that we failed because of something. I think we don't have like the configuration set up. It's not sure where to find the right database yet, so it's not working, but it is here and it's allowing us to run. And then I think I put Nginx on here as well. Let's go to Nginx. Yeah, we do have Nginx, and I think we just have the default. Yeah, default. Yeah, so not a lot going on there just yet. All right, so those things are installed, but nothing else is done just yet. I am in the midst of working on a playground for this as well, so some part of this might be me coming back to here and filling in bits on the playground, but lots of this will be me working through this so that I know what to write into the playground. So I do have all this stuff installed. I have these things installed. Docker, that's what I was doing on my local host. Method 2 right here is where we're at. So I'm going to actually edit this because we do want Nginx also. Edit. And then I actually needed to download this. Did I save that URL? Let me check something. Nothing there. Okay. You never seen an empty Nginx page on the internet? You're probably new to the internet. Yep. Or especially setting up your own server. Once you set up a couple of servers, you'll get really familiar with either Apache or Nginx little default pages there. Let's see. Playground's coming along. Still needs the ability to search, as the older notes are starting to get completely buried. Oh yeah, needs like a indexing type situation or something. Okay, I did not save it, unfortunately, and I don't. Oh, okay, well, actually, we do have both of them here, but we also have two of them. Okay, so what I'm going through in my head right now is which one of these two things was the one that worked, because the deal is I downloaded one and it worked, and I downloaded another one and it didn't work. I think that I ended on this Arch one for the Raspberry Pi. It says Ubuntu, and the Pi is not on Ubuntu, but I believe that that was the one that ended up working. I'm going to try to verify that by going like... I mean, we could check the history. That's all right. We'll verify it this way. So I'm going to move PostgREST to... put that to working, and then I'm gonna figure out how to tar a thing. I don't know off the top of my head how to unzip tar dot. Is it GZ or XC? It is XC. It's tar dash X XF. Okay. Tar dash XF, and then we give it the tar file. Can I give it a name as well? PostgREST 12. So I'll do the Ubuntu one because I'm pretty sure that's the one it was. Can I give it a name too? -C directory. That's a directory though. It's file expressing specified files. File 1, file 2. I don't see a rename. That's fine. We'll just do this. I'm pretty sure it's gonna rename it as just as PostgREST, like the one that I moved a minute ago. Yeah, I created this thing right here. Which is the one that worked. Because this actually starts and says stuff. If you run the other one, the non-working one, which it turns out is this one, which I'm about to delete right now, it tells you it's the wrong architecture or something like that. I forget the exact error, but it says it doesn't work. Okay, so Ubuntu Arch 64. So I'm going to put that in the guide where to get the specific one. So you need to go when you are installing this on the Raspberry Pi. Let's see here. Install. I guess I was in the tutorial. It says package manager and it says Pacman, but I don't have Arch, and it says Nixinf, but I don't have that. Latest releases. This is where I got it from. Direct install. Install those two things. And then we need to install... How big is this header? Sorry, that's a header. Heading 3. Let's see. Well, actually, method. So this goes for both methods, actually, because you need to get PostgREST either way, actually. So we're going to go to a whole new section here, which is a header 2, I believe. So we're going to say, I'm going to call it download and unpack PostgREST, because you don't really install it. May the 4th be with you, yeah. Happy 4th. Subject keyword category. Library similar to learn could be helpful. Speak the devil. The reason I specifically got into Playground most times is to find something. You've written CGrubber. Currently half 2-page back until I see. Yeah, that would be cool to get some kind of search going on there. Or some kind of like tagging system or browsing section or something that kind of keeps stuff categorized and relatively fresh. Let's see. Okay, so go to access the PostgREST release page here. Download the latest version for the Ubuntu Arch. Let's say download the latest version that is labeled, or I don't really want the link on that. Arch. Oh, that's tragic. It didn't save either. Yeah, well, that's dangerous, apparently. So the thing that just happened is... oh, sweet, it's still here. Okay, nice. Save it before anything. The thing that just happened is I pressed Control W because inside PyCharm, Control W will, like, grow your selection in a sort of smart way. So if you, like, put your cursor somewhere and Control W, it will jump, like, outwards by 1 unit of whatever it thinks you're trying to highlight. Basically, it's got different rules for different strings, but and I've gotten really used to using that. It's actually really handy, but I tried to use it in the browser here. I tried to highlight this and then Control W to get this, but in the browser, Control W closes the tab. It's not what we want. Should I keep that one as the link? So that technically you would not necessarily have to go to that page? I mean, I really want to encourage people to go to the page and get the newest one, though, is the thing. Don't even think I'm going to link it, honestly. That was tar x f. Then it's just your file, which for me was that one. Gonna wrap up house remodeling, planning to put a bunch more content in the playground. That search and keyword capability may become impractical info source. That after unpacking, you should be left with an executable application named PostgREST. When the time comes to launch it, you can do so with a command like this. Next up is setting up database and tables. Search for where looks great, just doesn't work on Playground. Okay, so for creating the tables, we are using the set up data value. So we need to set up a few things, actually. Let me check the order that this tutorial goes in. So it tells us to create the database for the API, but it's telling us to create it inside Docker, which we're not doing. But we do need to do the stuff that it's telling us to do here. So it says create the schema first. Then it says create the table, which effectively defines like a data object that you're going to have an API endpoint for. And then in this case, they're creating a couple values too, which we don't need to do. So we need to create the schema. For me, that's in this file. Yeah, create. So I created these files as .sql files for now. It has create schema API. It has create table. I called my table data values. And then each object in the table, each row has an ID, a value, which is number, a tag, which can be text, but it's optional. Well, it says not null. Maybe it's not optional. It could be empty, I think. Type text not null. So type, the idea there is like it could be a temperature reading, or it could be a humidity reading, or it could be a gas reading, or it could be an accelerometer. There's different kinds of readings it could be. So that's just a string that's going to hold unique identifiers of which type it is. A timestamp, which defaults to the current time. And that's all it's got. So this will create us a table that has these columns, which is then where we're going to be storing our data. So create the schema is the first step. So we'll say, I could just use this one, I think. Create schema. First step is, we don't even really need to be like that, right? The first step is to create, just realized I covered up a bunch of my windows. There we go. First step is to create the schema inside of the database, inside of the database. Which, actually, I'm gonna make the executive call. I think the first step is to create a database to store everything inside of. I'm going to change the way the tutorial works here. Where's the config file? Right here. This is the PostgREST with the T config file, and it's telling it where to find the database, in this case, localhost port 5433. But it's telling it right here which database to use, and it's using a database called PostgREST, which is the default one. I'm pretty sure that does exist, but I'm also pretty sure I don't really want to use it. How do you list databases? Is that D? Not find any relations. Or DT? Or L? Okay, it's not formatted so great, but it was the right answer, I think. Okay, so yeah, that's the list of databases. Right now we have 3 databases. So if you have never used PostgRE before, one of the really cool things about it is PostgRE, it's a database server software. It can host multiple databases inside of it. By default, you get these 3. I did not create any of these. They all came automatically. This is the one that this tutorial is going to be having us use right there. I don't really want to do that. I want to create a new one. So we're going to do that. And we can just owner. Yeah, we'll make it the same owner for now. But eventually we could probably have a more limited owner, I would assume. Let me back out of here. So create, is it create DB? Create DB options, DB name description. So we want to do that. Create DB owner, host. Password. Okay, let's go. So I am in the Postgres user. That's the first thing you need to do is get yourself over to the Postgres user. In order to interact with the PostgreSQL server, you need to switch users over to the Postgres user. One thing that is a little unfortunate is we have PostgreSQL, which creates a user called PostgREST, R-E-S, and then we have PostgREST with a T on the end, the project we're using to create the REST API, which does get a little dicey with all of them together. See search on Playground, and if I search Sen55, it turns up what I'd expect, although just not Sen5. Oh, that's interesting. Maybe it's on like full strings instead of substrings. All right, I am gonna cut this sudo su Postgres. I'll save this, but once you have switched to I always try to do markdown, Postgres user, you should see a prompt like this, which means I'm gonna I don't even know why I'm trying to keep that. Let me actually put this too. Switch to the Postgres user and move and change directories to its home directory. An extra space here. Okay. So once we have that prompt to create the database, use a command like this. So that is create DB. Whoops. Create DB -- owner. I'm just gonna make it Postgres. Although my gut instinct is it might be better to have a different user. And I know we're going to create some users as part of the process here in a little bit, but I'm wondering it might even make sense to have one there as well. I'm not sure. Phone guy, do I have a 7-inch TFT RA 88.5? I don't think so. I've been living with RA for the past couple of... I've seen you've done a lot of work on that. There's no display I/O for it yet. I don't think so. I have the from like a long time ago, from a year or two ago at this point. I have the hack tablet that K-Match created. I have no idea if that's the driver. It is like a 7-inch screen, I think, 7 or 8. But it does, as far as I understand it, I believe it does have display I/O now on that one through the what kind of display was that? Was that parallel, or was that dot matrix display? Yeah, I think it was a dot matrix display. I think that's the right name, but I'm not 100% sure. And I don't know the chip, so I have no idea if it's that chip, but I would guess it probably is not, because it's from a while ago. This one I think is newer, right? This RA 8875 I think is a relatively new one. I should look into it. I haven't... I've not been keeping up with the new stuff as much. We have here. Okay. 372. That's an interesting size. Okay. So it's like, what are you? You're in for $70 for the driver and the screen, basically. Then you get your choice of sizes, pretty much. 5, 7, 4, 4, 3. And this is a, what is the main board? Oh, interesting. Wait, so is it a, interesting. Does it have a microcontroller? Or you need to also use a microcontroller? Oh, that's nice. I never noticed these little arrows. You need to use a microcontroller, I'm guessing, because you go... So it's saying power in, it's saying probably backlight in, SPI bus, clock, MOSI, chip select, reset. So all those are in. MISO is out. So you need to... Okay, so you run it on another microcontroller, you connect the SPI bus. Yeah, I don't know under the hood how it works. I would assume it's like theoretically possible for it to work with display I/O, but probably what it will need is the layer inside the core that translates ultimately what are bitmaps, but like it's got to go higher level as well. So I'll say groups, like it needs to go through the groups, filter its way down to the tile grids and the bitmaps inside those groups, and then it translates that to a final sort of array of pixels, and then it needs to send it on the bus. That's kind of how display I/O works at a high level, as far as I understand it. So it would be just taking that high, someone's got to write that glue that's like, take the high level group tile grid down to bitmap, get it into the format that this thing wants it in, and send it out the bus. Nice. With a feather. Can't even read a single pixel. Oh, yeah, I mean, I will say for one thing, that's something that display I/O will not help you with either, because I don't think, I think maybe K-Match experimented with it at one point, but I don't believe it's just widely supported in the core or anything. I don't think we really have a way to read pixels back off of a display, except for with, there's like bitmap saver library, which uses display.getLine or something, get row or something like that, that fetches a row of pixels, but alright, so we want to create DB, we want to go owner. Was I typing this into the learn, or did I just erase? Okay, yeah, it was here. Owner Postgres. We'll do it here, and then we'll copy it. So create DB owner Postgres. I guess I don't know if we'll need anything else. Let's just try that, I guess. And then the name would come afterwards. DB name. So I'm gonna call it IoT data server, IoT data. Actually, I'm gonna just call it IoT DB for IoT database. Let's see if that works. We might need a host. No, that worked. Okay. Probably just defaults to localhost. So now we have IoT DB right here. So we have a new database. And that database is like, it's fully contained. Everything we save inside of there is inside of there. You know, users can have access to like particular databases. So it can kind of be all segmented out and stuff like that. Okay. We have a new database. That's how we created it. Then the next thing we want to do, the next step, is to create the schema inside of the database. In order to do so, we need to get into. That's really not the best way to describe it. We need to get into the PSQL shell. To access it, make sure that you have switched user to PostgREST and then run PSQL. Once you've entered the PSQL shell, you should see this prompt. See, let's say a prompt like this. You should see a prompt like this. If you have different versions, maybe it's like slightly different, but let me also back up here, say a command like this. Note that you can choose whatever name you'd like for your database. I chose IoT DB. I don't really like the way the period looks at the end of the text, at the end of the code thing there, so I'm gonna cut it out even though it's improper. How's bitmap saver work? Yeah, it does. There's like a row. There's one function on display that accesses a full row of pixel data. And then it basically loops over that. Sorry for the interruption. No worries. You don't have to apologize for that at all. I would say I take after Scott in that is I'm happy to like answer questions or go on tangents or whatever. It's like, I don't know. I'm not diagnosed or anything, but I do think I'm probably like ADD to an extent, but I also don't like try to resist it. I'm happy to go with the flow sometimes. So never need to apologize for that. Once you've entered PSQ shell, you should get a prompt like this. To verify that your database was created successfully in the previous step, you can run the list command by typing /l and then pressing enter. It should output a table containing the databases that exist inside of your system. You may need to adjust your terminal or font size to make it look legible. To make it look, to make it easier to understand. I want text, actually I want code. I'm pretty sure those are alphabetical, but I guess I'm not positive. I think the only reason mine is listed before PostgREST is that they're alphabetical. I can could find out if that's the case. I can't show you though. Nope. Yeah, that's totally just alphabetical. The first column shows names of the databases. They're in alphabetical order. Look for name you selected in the list and verify it exists. If it doesn't, go back and repeat the create DB step again. Let's just say go back and do the create DB step. I mean, like if you ran it, it will be there. So it's weird to call it repeat again. I mean, they probably tried to run it. All right, and now we finally are to creating a schema. I'm actually just going to cut from all the way up here, even though we've bounced it a bunch of times now. You can just put it here. Say maybe give it a create schema. And in order to do that, I believe I'm pretty sure you need to like connect. Pretty sure you need to connect to the database that you want to modify. Which I think by default you probably connect to PostgREST. PSQL check which database connected to. Select current database. So I am currently inside the PostgREST database. If I just start creating stuff, then it's going to be created inside PostgREST, which we just talked about a bit ago is not what we want. We want it to go to that IoT DB, so I need to change or connect to a different database. So PSQL connect to database. Not PS. Or like open database? Connect to database by name? I guess -C, but I don't positive. Connect. Yeah. Okay, so we just go /connect, the name of the database. I'm actually going to put two commands here. Do we need a semicolon? I think we should put the semicolon. It may not be strictly necessary, I'm not sure. Next step is create a schema inside. First connect to the database we created. Just say first connect to the specific database we created. Then run create schema API. How do you PSQL list schemas? I think it's S? DN, of course, yes, DN to list the schemas. Obviously. Probably like makes more sense than I give it credit. List of schemas, public. Row. Ah, well, I didn't run it yet. I only put it in here. Oh, I can't copy that. There we go. There we go. Now I did DN, which lists schemas, and we can see name API right there, which is the one we just created. If it's successful, you will see create schema printed out. You can validate it by using /dn. Print a list of schemas and look for API. In the list. All right, I gotta run to the restroom, so I will BRB. Almost out of coffee. It's a shame. Okay. These programming gloves back on here. Let me start up some new tunes. All right, create the schema and then create a table. Create table. Is there a sequel? No. SQL code creates a table and specifies 1, 2, 3, 4, 5 columns. Specifies 5 columns go into the table. No. ID an auto incrementing number that serves as the primary key. No, value. Number value that will hold our data readings. Tag. Optional text value that can be used to categorize data however you'd like. Type. A text field that declares the type of this data value, e.g. temperature, humidity, etc. Timestamp, datetime field that automatically sets to the time and time a reading is saved. Feel free to add or modify these columns as needed. You are storing different types of data or would like to associate more meta information with it. SQL column types. Refer to the PostgreSQL documentation or a comprehensive list of data types. Needs to be pasted into the PSQL shell prompt. Save that, and we'll put the output from it after. So we'll copy that. Looks like it says we need to put that into the PSQL prompt right here. Paste that. It does paste as a multi-line thing right there. Oh, the prompt should change actually. So when we connected here, the prompt should change to this. Let's note that before we blow past it here. So that was after connect. Let's put it here, I guess. No, let's put in this one. After connect IoT DB, the prompt should change to include the database name, G. Goodness, cat is like tearing up a. Luckily, it sounds like it's the cardboard thing specifically for being torn up, but sure sounds like he's going to town on it. All right, I think we're ready to send it. Lamaroni, nice and simple. Create table. Yeah. All right, this code needs to be pasted into the shell prompt. If successful, shell prompt, and then press enter after pasting it. Be mindful of the semicolon at the end. You forget that, it won't work. I'd be mindful of that. So then we'll just say if successful, it will print the output. Did I copy that? Yeah. Verify you can run something slash, I think it's DT to list tables. Or that's not going to work though, because we need to list the tables in the schema and find any relations. Yeah, that didn't work. List PSQL list tables in schema. The schema, I'm not super familiar with the whole architecture, but schema I think is a thing above tables. You could put tables inside of a schema. in all schemas in a particular schema. /dt. So my schema is called API. API.star. Yeah, okay, that worked. That gave us a list. It tells us the schema's API, the name of the thing is data values, which was the name of the table I chose right there. The type of it is a table. The owner is Postgres. All right, so we've created a database. We created a schema. Now we finally have created a table inside of that schema, or underneath, or whatever. I don't know the proper terminology, if it's actually inside or what, but how's it going, Fede2? Nice to see you today. All right, so put this back. So DT and then API, yeah, so we'll say you can run this. So it was DT, but it actually had more to do. If you just do DT, it doesn't work. It's looking at the context you're inside of. Probably you could somehow get inside of the schema yourself so that would just work with DT/DT, but I don't know. Just did it this way and it worked. To list the tables inside of the API schema and look for the one named data values. The one named data values. Or whatever you chose. You changed the name. You can also change the name of the table if you'd like. In my case, I chose I'm going to say data values, because that's really the name of the table. For the name of the table, it's inside of the API schema, so the full name is API.dataValues. Should we put the output? Oh, that's text. No, sir. Okay. We have almost enough to actually make it run at this point. We wouldn't have any data in it, but we are close to having enough. So it says, all right, yeah, let's do this stuff. So we've created the schema, we've created the table. In their case, they're inserting into the table. I'm not going to bother with that. I'm not going to bother with that right now. I don't know the right syntax for the way that I've done mine, where because it's like tag and type and value and all that stuff. I have we'll end up creating stuff in the database using an HTTP post, which we'll get to. So it says next, make a role for the anonymous web requests. When a request comes in, Postgres will switch to this role in the database to run queries. So we need all three of these. We are going to have to change API to-dos right there to API values, data values, actually, sorry, is what I used. So next, so let's call this, we'll make a new heading. We'll say this web anon user. It's underscore? Yeah. Web anon user. Next, we want to create an a specific user that the database will use when anonymous web requests come in. Create role webanon, no login, grant, where was that from? I don't know. Grant usage on schema API to webanon. Okay, grant select on API dot data values, in our case, to webanon. So it's a little pedantic the way it's worded, but it's pretty straightforward as far as like what it's going to do, right? Like it's not necessarily a way that you talk, but it is a way that you can understand pretty easily. Let's call this create webanon user. And then we'll say here, if you've used a different name for your schema or table, then substitute them in as appropriate. Substitute them into the appropriate places. Okay, let's run those. Copy them out of here. You can do them one at a time. Yeah, let's do them one at a time. Nah, let's try it all at once. Because if you do have to do them one at a time, we should specify it, so... I don't know if the space will matter. I don't think so. Alright, yeah. So it will say create role, and then grant, and then grant. So the first one, if that's successful, you'll see create role. The next one is a grant command. So if that's successful, you'll see grant. The last one is another grant. If that's successful, you'll see grant. These commands can be pasted all at once or individually, one at a time. If successful, these commands will output Okay, I'm gonna link to here as well, actually. Let's, what do they call it? Get it running. They're taken from the official, are modeled after the ones in the official PostgREST container. Commands used are the same ones we will use directly on the RasPi. Okay, so we have now granted the roles. What's next? It is... It's good prep. Yeah, that's just describing the last bit. The Webanon role has permission to access the things inside API schema and to read rows in the to-dos tables, or in our case, the data values table. It's a good practice to create a dedicated role for connecting to the database instead of using the highly privileged PostgREST role. So we'll do that. Name the role Authenticator. Also grant it the ability to switch to the Webanon role. We also want to create an additional user in the PostgreSQL system. Did they phrase that? Create a dedicated role. Let's use the exact. We also want to create a, let's use the exact same thing. A dedicated role. Dedicated role. Role and user are synonyms. Synonyms. In the PostgreSQL system. To instead of, rather, create a dedicated role to use in the system to use for connecting to our database instead of using the highly privileged yeah, thank you, highly privileged PostgREST user, right? Yeah, PostgREST role. Maybe role is like inside of Postgres, whereas user could mean like Linux user, because we have a Linux user called Postgres as well. We also have a role inside the database that's called Postgres. And that is currently the one that we've done everything under. That's the one that owns the database and all that stuff. But this is saying best practices, don't use that one for your connections. Instead, create a new one, which we're calling Authenticator. We're giving it the ability to kind of like change into Webanon, and we're giving it a password as well. These SQL commands will create a dedicated role. Grant it permission to change into the Webanon role. Change the password to something secure. Keep it a secret. Oh, yeah, is it? We should probably just put this up here, I think. Say the following instead of these, just to be more specific. That's the upcoming ones. Create role Authenticator. Create a dedicated role named Authenticator. I kind of want to change it to Authenticator. I wonder if you can have emojis in the name. Can I have an alligator emoji in the name? That'd be pretty sweet. Not gonna lie. Or the password, actually. That'd be pretty cool. Emoji passwords. Create role authenticator. I will use a different secret password of authenticator, since that makes me chuckle. And then we want to grant that role. We want to grant we want to grant authenticator the allowance to turn into Webanon, basically. We grant Webanon to authenticator. If successful, the commands will print this output. Create role and grant role. Now I think we're actually pretty much ready. Yeah, so we can quit out of the database. Can you emoji in here? Anybody know? Let's call this our minimal database. Our database is ready to go with everything it needs to be a minimal data API. Nice. Crocodile exists, but not gator. I'd be fine with that. That's close enough for my purposes. Authentic Croc still has a nice ring. That's true, actually, it does. It show up as a Unicode character, but no guarantee it'll work for all languages. Yeah. Okay. So we can say to exit out of the PSQL shell, enter /q and press enter. Type. Right. That will drop you back out to the Linux shell prompt under the PostgREST Linux user. You can press Control. In fact, it's not even really you can, it's you should. The next step is press Control D, break out of the PostgREST Linux user and go back to. So whatever your user is. In my case, I actually put my username instead of Raspberry Pi. But let's just say go back to the base user, like Pi or whatever you set up when you imaged Pi. If in doubt, you can always close the connection and SSH in again to a new session. Which I'm doing this all through SSH. I guess I don't know if I mentioned that before. I suppose you could do this all on the Pi itself, but I don't know. SSH is more convenient, I think. Okay. And we are finally ready to run this. The only thing we really need to run that we don't have so far is a config file. So I have a weather IoT config, but I'm actually going to change that to a data values IoT.conf. And inside of there, we want these things. So our schema is API. If we had changed that, we would need to specify it here. Our anonymous role is WebAnon. Again, if we had changed that, we would want to specify it here. Our connector URL, or URI, I guess, is Postgres authenticator. If we had used a different name for that authenticator role, we would want to set that here. We did use a different password, which was authenticator. Obviously, I won't expose this anywhere online since you all now know my password. Authenticator. One gotcha that I happen to know of, just because I know of it, because it bit me in the past. If your password contains a colon, that's a problem. You need to escape it, I'm pretty sure. So yeah, if you have a colon, be careful in your password. At localhost, that should be fine. Our Postgres server is actually running on the default port, I'm pretty sure, which is port 5432. And then Postgres, that's the name of the database, which ours, we created a new database. It was IoTDB, not Postgres. We don't want to go into the Postgres database, in my opinion. We want to go into our own specially created database just for this. IoTDB, perfect. So there's all of those. Now run the server with PostgREST /PostgREST and then tutorial.conf, so the name of the config file. See, as it would need to be for the names that I've used, you can update it to your own names as needed. Save a copy of this file under a name like, what did I call it? Data values IoT conf. Run the server, execute the PostgREST command, and pass in the path to the .conf file as an argument. I'm going to say / since this tutorial is all about downloading the one. Apparently you can install it if you're on Arch or some of the other places. Probably I could even figure out how to install the one I've gotten, but I'm not going to mess with it. I'm just going to download and use the runnable one because that's convenient. I kind of like these to be codified. It's maybe not, I don't know if it's proper exactly, but I kind of like it. I guess one of them is supposed to be bold. Is that file names are supposed to be bold, maybe? That's an official Learn Guides, though. Should put a tip about password not allowing into the guide. Yeah, we can do that. Secret. Let's see. Your password can contain special characters, but some characters may require escaping when you go to enter them in. In particular, leave the colon. Maybe that's only if you do a PGPass file. I'm not sure. I know in some cases you do have to do it because I may or may not have a database that may or may not have a colon in its password, and I may or may not have had to work through figuring out how to escape it. All right, run that command, pass in the path to the conf file as an argument. Just gonna do a code /PostgREST, and then our file was data values IoT.conf. Bam. Right, we did not save that on the Raspberry Pi, so we'll just go nano. Oops. There we go. So now we got some better stuff here. Starting the version, attempting to connect to the database, connection successful, listening on port 3000, config reloaded, listening for notifications, schema cache loaded. So listening on port 3000. If we go and hit, not localhost, the Raspberry Pi, which is 116 port 3000, bam. Should tell us in our thing here, I think, right? No, just kidding. Doesn't tell us in here. But we can tell it's working because this returned a page to us. So by default, this returns an API documentation that's actually in JSON. I think this is like a standard format, OpenAPI JSON. I'm not familiar with it. I'm not familiar with it, but it looks like structured and very standardized. And I think I know there are projects like what's the name of it? It's Swagger. Is that the right thing? Swagger. Yeah. I'm pretty sure. OpenAPI specification. I'm pretty sure there are some things like Swagger is one of them, and I'm guessing there are probably others at this point because it's a really good idea, and I could see how different groups of people might want to do it differently. But I think what these things are is like a front end that could actually consume this JSON and turn it into documentation pages for us. I don't have that stuff set up. I don't exactly know how to set it up because I've never done it before. So that's not what I'm going to do right now, but I'm pretty sure that's what this page is basically like capable of doing. or it's like capable of being done with the data that this page gives you. The next thing we could look at is the actual data in the system, which is right now there is not any, but we can still data values right there. So we get back an empty JSON right there. In their case, they got back some actual data because they put data into their database back up here with those insert commands right there. Here's when I need to use data for requests anytime I see JSON. Yeah. So theirs has some data in it. Ours does not yet, but that's okay. Create data value. So this is just using curl, which is a command line HTTP client. All right, so we could try running this. Didn't really give us the status or anything. I don't know how to print the... There's an error there. Not sure how to print the status. Response is unauthorized. Okay, we should have gotten this, so I'm not sure why we didn't get that. Oh, okay, I did to-dos. And it needs to be data values. I'm surprised that it didn't give us an error. Okay, there we go. Now we got that. So I tried to submit some data. This is how we would submit data right here, is by sending a post to data values. We give it a JSON body with all of our different columns in the database, basically. Value was our numeric. Tag is a string. I just made that one up. Type is a string, and I chose temperature for this example. We try to send that post, but it tells us, hey, you're not allowed. Permission denied for the table data values. And that gets us to the end of tutorial 0, which takes us into tutorial 1, the golden key, which is talking about how to set it up to actually work. Which I will continue on to do, but I probably will not finish it today on the stream. Once that is running, you should be able to access the PostgREST server by opening a browser on your on a PC connected to the same network as the RasPi, and navigating to the RasPi's IP and port 3000, e.g. Is that going to be actually linkified? I don't really want that to be linkified. See, if everything is working successfully, you will see a page full of JSON data which contains open API specification of documentation for API. Heading 3. Posting data to API. You could also navigate to data values or whatever your table name is. Fetch the data values stored in the database. Control C in order to exit out of the server and stop it from running. By default, let's see, by default, it's not possible to post data into our database without authenticating. See, this is a very good practice to use, even though it means we need to jump through one more hoop in order to be able to submit data. This section's steps are modeled after those found in the official tutorial 1, the golden key. Golden key. From the PostgREST documentation. So adding a trusted user, create role, they call it to do user, so I'm going to call mine data value user. So create role data value user, no login, grant data value user authenticator, grant usage on schema API to data value user, grant all on API.dataValues to data value user, grant usage, comma, so and select on sequence API.dataValues underscore ID underscore sequence to data value user. So we need to go back to Postgres Linux user, and inside Postgre shell, create data value user, grant data value user to authenticator, grant usage on API to data value user, grant all on API data values, that's our table, to data value user, grant usage and select on sequence API dot data values underscore ID underscore sequence to data value user. Create role data value user, no login. I'm going to keep these in a text. But we'll eventually be able to copy them as the output. It's really, yeah, okay. Let's see, create role. So let's grab the next one. Create, grant data value user to authenticator. Grant usage schema API to data value user. Schema API does not exist. Okay, so the reason that is because we're not inside of our database. I created that other database, but we're not inside of it. So this succeeded and this succeeded because roles and grant permissions are outside of databases. Those exist kind of within the system, but schemas are inside of databases. So in order to do that, I actually need to connect IoT DB. There we go. Technically, I could also switch user maybe? No, probably not actually. We need to use the Postgres user because we're like setting up the user that we would switch to. There we go. Okay, now we succeeded. Grant access to the table. And then lastly, it's granting access to the ID sequencing ability so that it can save a new ID basically each time. There we go. So we got create role, and then grant. Print these respective outputs just to say that they go in order basically, and that you can run them one at a time. And these ones I would recommend doing one at a time. I recommend running these commands one at a time. Okay, if successful, it will output these things, which are these ones. I want that to be code though. Okay, what's next is make a secret. Let's create a password and provide it to PostgREST. Think of a nice long one or use a tool to generate it. We need a password to use to secure our tokens. So either think of a nice long secure one or create one using Python with this command. Create one. I'm going to change that to be commands, and I'm going to say shell and some stuff. Import secrets. What are we going to do with this password? Yeah, I'm going to put it in the conf file. It's talking about doing it this way. I don't know. I don't really like this. It's like, I don't really know what this command's doing. I don't really like the idea of running a command that edits the config file directly rather than just generating your thing and like copy pasting it in a text editor. That just feels a little bit more controlled, I guess, but it's just because I don't understand this. So anyway, we're going to generate it with Python. I would like to keep my connection, I guess, so I'm just going to make a new SSH 192.168. Actually, I don't even need to do this on the Pi. This could be local on my computer. So we could just go Python. We can go import secrets. We can go secrets dot token URL safe. I think I can just give it a number. Needs to be at least 32 characters. Yeah, by default, that's that came out as 42 characters, so we're good to go there. Or why we got 42 and I entered 32, but whatever, it doesn't really matter. Import secrets dot token URL safe 32. It will print a generated. It will generate and print a secure password. I need to copy that. Copy that password. We're going to paste it into a new line in the conf file. I do actually want to be connected again, so we're going to go break out of Python. We're going to go SSH 68.1.116, which is the Pi. We're going to go nano the config, which is data values. I'm going to go JWT secret equals password we generated. I don't have any more. Okay, it's still in my clipboard, luckily. Use nano or your favorite text editor to add a new line in the .conf file like this. All right, then we need to sign a token I'm going to try to get through this part. I'm going to try to get a successful post, and then I'll probably wrap it up for the day. So save that, exit this. I'm just going to cat that so that I can make sure to copy this again. And I'm going to stop writing as much here, and I'm just going to try to get this part working. So we want to go to jwt.io because we want to create a thing right here. So our secret is this. I'm going to paste that in there. These are the default. We want some different things here, though. Role. So they're saying to-do user. Ours is going to be data value user. So for anybody that doesn't know, JWT, which is what this system is using, JWT is a way of having the server sign a data object and then send it to the client, and then the client will return that data object to the server. The server will validate that it has been signed by the private key, which the server will keep secret, which in our case is this thing. It will validate that it's actually signed with that key, and then if it is, it will be able to read the data inside of it and trust that, you know, the server is the one who put this data inside here, because the server is the only one who could have signed a copy of it successfully. And then it does, you know, validations with the public key and everything, I think. Also, I'm simplifying. Also, I'm not a security expert. Also, I don't actually know that much about JWT. So take everything I said with a grain of salt. That is all my understanding of how it works. Which could be wrong. It certainly is incomplete. Data value, what do we call it? Data value role? Data value user? They say to-do user. Ours was, yeah, it's data value user. Data value underscore user. Yeah. And then we don't need John Doe or this other thing here. We do need valid JSON though. I don't like the way it always scrolls down. So role data value user, okay. Let's do that. I think password we generated. Yeah, I think that's all we need. So that's going to generate this token right here, which we can copy. And then with that token, I'm actually going to create another copy of this. I'm going to say, so I have create task here. I'm just going to copy paste that to create task pi. And then we're going to take that token, we're going to replace this old token, which was when I was running inside Docker. We're going to save that. We're going to fix this to be data values. So now this is using curl. It's going to take our token. It's going to put it as a header that says authorization is the name of the header. The value is bearer space and then the token, which is very common authentication scheme. Ours is a JWT token, saying content type task. This is still a task. I don't actually want task though. I want data value. Okay, yeah, let me copy that. I should have called this data value. Oh, this is all wrong. This is very wrong. Hold on. Hold on. There we go. So let me call this create data value pi, not task. Task is the sample application, the tutorial, the to-dos application, but I'm doing the data values, which is slightly different. All right, so I think that's all we need. So create data value pi. We modified our config. We set up our user. We did all the things. We have our token. We should be good to go, I think. So we need to run the PostgREST server. Back here. Okay, we created all this stuff. I'm just going to exit out of that. We run. Let's make sure cat, let me just double check cat data values. Yep, that has the JWT secret. So we run our server again, PostgREST. We give it our config file. It does its thing. Now we should be able to send our post. It's not localhost though. Be able to send that post with our JWT token. It's been signed with our secret. Invalid signature. Shoot. Shoot. Ah. How do you reopen the last closed tab? Thought there was a key cut for that. Ah. That's so aggravating. Just trying our best around here. Disclaimer though. Not sure about that, maybe. Make sure the top is right. HS256 JWT role to do user. Ours was data value user. Okay, we want to put this weak secret. I wonder if the dash or something is messing it up. Base 64 encode. Secret base 64 encoded. Why does it do that? Yeah, that's changing live. So like as soon as I change here, it changes here. Let's try this again. Didn't print anything, which I think is probably actually a good sign. So if we go back to here and we go data values, I'm just going to refresh. Bam. There's our data value that we just added. So that came from our post. I don't know why it wasn't working the first time. Probably I miscopied the token, I'm guessing. Control-Shift-T. That's probably it. Yeah, I tried Control-Alt-T, but I was wrong on that one. Control-Shift-T, that does sound right, though. Thank you. All right, so that created our value right there. And to kind of bring it all home, to wrap it up for the day, for now at least, device workspace, I actually have, I think, loaded up over here, code post BME readings. So this is some CircuitPython code that actually posts a reading to the server. So if I change this to 116, let me make a new copy of this actually, instead of post BME readings to pi. So we need a different token, which is the full token, the JWT token. So that's just going to take one reading every 10 seconds and then send it to the server using a post, using the exact same way we just saw with curl, but obviously generating the data inside CircuitPython, and in our case, putting a real value from a temperature sensor which I have connected. Lost my eye there somewhere. That will take a reading, and if we refresh here, we have another value. And in my case, I just made up these names, Cornelius and Glenmarch. I have no idea where those came from other than my head, but I made those up, and the CircuitPython device, in my case, it's a Feather S3, is submitting that. If I keep refreshing here every few seconds, we'll see new values pop in every 10 seconds because that's what my microcontroller is doing there on a 10-second thing. So these will now sit here and just create data into my system. The next thing that I would do will be start creating an HTML page that will pull this data back out of the system and populate it onto a graph. But that will be for a different time. So for now, I will consider it a good stopping point. We definitely got a lot done. Thanks for sticking with me. I know this is a little more on the kind of like documenting and tutorial writing side of things. Usually I'm a little bit deeper in the code and just coding and doing whatever it is I'm doing. This time we're doing a lot more writing of documentation and stuff. So if this is a kind of thing that is interesting to you, let me know. Or if not, let me know that too, because maybe I can kind of tailor what I do on stream around what folks find interesting. In any case, if you want to check this out, it is in the playground system, but it's not, I don't think I made it public or whatever. Maybe it's public by default. I don't know. I haven't done the full on like share, finish, it's ready to go just yet. So it exists, but I'm still definitely working on it. Not in a state of being completely finished yet. But yeah, if you are interested in creating a very simple data storage system, like and accessing it over the network, I think PostgREST is a pretty neat tool for being able to do that. So take a look at that if that's something you're interested in. If you want to see the next part of this, I would say you can follow me over on Twitch or YouTube, and I will try to stream either tomorrow or sometime in the upcoming week, kind of like following on with what I've gotten to now. So we'll create the HTML page to pull that data back out and stuff. So take it easy, everybody. I hope you all have a nice day, have a nice weekend and all that stuff. I will be back on Friday for certain. For the deep dive this week, like I just said, I'll try to pop back on at some point to do the HTML and the graphing for this. That'll probably not be on deep dive, but sometime before. Deep dive on Friday, and then I'll be back at the usual time, Saturday morning, 10 a.m. Central, for next Saturday as well. So see you then, and have a good day.